Okay, today we are going to be looking at section 3.4. We are moving on. I'm going to use graph paper for these notes. You don't necessarily need graph paper. All this can be done on regular paper. I put some in there. In-person students, I hope we took some home. It just makes things a little easier to organize. But what we have here is, I will title this is 3.4. And we're going to look at graphing linear equations. So they're going to make lines, but we're going to look in standard form. So there's going to be another way of looking at linear equations. So far we've looked at linear equations in slope-intercept form as y equals mx plus b. Now we're going to look at it in called standard form. Standard form is simply when the equation looks a certain way. Standard form of a linear equation is the following: ax plus by is equal to c. So when I see a linear equation and I have some coefficient a multiplied by x, and I'm adding or subtracting some coefficient b times y is equal to c. When it looks like this, when my x and my y are on one side of the equation, I have some number on the other, some constant. This is what we call standard form. I'm going to put some parameters on this. In Algebra 1, as we've been saying all year, a, b, and c are real numbers. We're going to be dealing with only real numbers except for a certain part of a chapter coming up. And I will say a and b are not both 0. And hopefully that makes sense to you, because if a was 0 and b was 0, well, this whole thing would be 0. One of them could be 0, but we don't want both of them to be 0. Here we go. We're going to revisit horizontal and vertical lines. And we've looked at these just briefly a couple of times. Horizontal and vertical lines. Horizontal line, vertical line. Horizontal, you're looking out over the horizon. Remember, a vertical line has a slope of 0. I'm sorry, a horizontal line has a slope of 0. A vertical line has a slope that is undefined. So let's look at this real quick. I'm going to make a quick little XY coordinate plane here. Nothing too fancy. And again, graph paper certainly helps, but it is not necessary. It just makes those nice, clean and crisp. Here's my x-axis, my y-axis, and I'm going to put a point right here in a horizontal line going through that point on the y-axis. I want us to think about this point right here. When you have horizontal lines, when you have a line that passes through the y-axis, your x-coordinate will always be 0. I'm going to call this point 0b. 0b. The equation of this line would be y is equal to b. When you have y equals anything, it's a horizontal line. And it simply crosses the y-axis at whatever that y equals. And it should make sense, because if your x is 0, and remember, back to functions, if I plug in 0 in for x there, 0 times anything is 0. That's just going to go away. You're going to have y is equal to something. The b in this case happens to be 1. The c in this case happens to be the y coordinate, which we call b. This passes through, and this is important, it passes through the point 0b. And what you're going to find out, and why this is useful, is because I can get a point at which any line crosses the y-axis if the x is 0. Any point where a line crosses that y-axis, the x is always going to be 0. You're not moving left or right. I'm going to look at the vertical line here. Put this, I'll just make a little XY coordinate plane again. Nothing terribly fancy. Does not need to be fancy. Here's my X, here's my Y, and now I am going to make a vertical line right here. I'll do that in red. That's the line that we're looking at. This vertical line is always going to have the equation x equals. X equals. And in this case, we are going to say x is equal to a. I'm just going to make a note. That's vertical. That's a vertical line. X is equal to a. And I'm just going to work backwards from where I started here. X is equal to a because I'm going to call this point right here the point A0. Doesn't matter what it is. I mean, I can see on the graph it's 2, 0. This would be the line x equals 2. Over here, this is where y is 2, would be the line y equals 2. And hopefully it's making sense. If you go back to standard form here, if your y is 0, that will go away and you have x equals something. And that's what we have right here. Vertical line. This passes through the point A0. Doesn't matter where this vertical line crosses the x-axis, your y will always be 0. It is going to tell you where the line crosses the x-axis if your y is 0. That's the idea and the basis behind using standard form. Okay. Here's a little example. We're going to graph y equals 4 and x equals 2. And to save time and a little bit of paper, I'm going to do this in the same coordinate plane. There's my x, there's my y. And again, you have the equation y is equal to 4. That means your x is 0. This crosses at the point 0, 4. 1, 2, 3, 4. Remember, x is 0. So if I look back up here to this, if x is 0, it's going to tell me y equals. I have an ordered pair of 0, 4. I can draw this line in. And that is the line y is equal to 4. X is equal to 2, you would have the ordered pair 2, 0. 2, 0. Because now y is 0. It crosses the x-axis right there at 2. I will draw that line in. That is a vertical line. That is the line. X is equal to 2. So hopefully that's clearing up a little bit. Of the vertical and horizontal lines. Here is how we are going to graph with intercepts. I'm going to flip this over, start a new sheet here. When we see something in standard form, you will also see that called that intercept form. And we are going to use that idea that we just came up with where they cross the x and the y axis to graph with intercepts. So instead of making a table, now I'm going to look at the equation and see if I can arrange it to put it in intercept form, and if I can arrange it, does it make sense to use intercept form to graph it? Another little XY coordinate plane, and yes, you're going to be doing a whole bunch of coordinate planes. There's no way around it. There we go. And I'm going to give you this line right here. I'm going to put a point here. And I am going to put a point here. I'm going to connect those. And I'm going to go back to using A's and B's like we did in before. The reason that we want to graph with intercepts is because I only need 2 points to find a line. And I know if this line crosses the x and the y axis, I know what the x coordinate is of that point, and I know what the y coordinate of that point is right there. Remember, something that crosses the y axis has an x of 0. I am going to call this 0b. Because remember, you have an x and a y. I am going to call this A 0. When it crosses the x-axis, your y is 0. When it crosses the y-axis, your x is 0. We call this point right here, that is your x-intercept. That point where this crosses the y-axis, this is your y-intercept. This happens to be your b in the equation y equals mx plus b. If I can find out my intercepts, I can have 2 points that are on the line. I can easily graph this line without even using slope, without finding multiple points. I'm just going to find the intercepts. Makes for a nice, easy way to graph. Here's how we graph with intercepts. I'm going to say use intercepts to graph 3x plus 4y is equal to 12. First thing you want to look at, use intercepts to graph. When you see something in standard form, you will also hear me to refer to this as intercept form, because it's set up very nice to find my x and my y intercept when it is in standard form. I want to get where it crosses the x-axis and where it crosses the y-axis. And to do that, I am going to take and I'm going to say let x equals 0. Because if I let x equal 0, I know I'm going to have an ordered pair of 0. I can find that y and I can find the intercept. Plug it in. Let x equal 0. I'm going to plug it right into this equation. 3 times 0 plus 4y is equal to 12. What's going to happen when I let x equal 0? That will go away, because that's 0. You are left with 4y is equal to 12. I divide by 4. Y then is equal to 3. So when x is 0, y is 3. Input of 0, output of 3. You have the ordered pair 0, 3. You have an x and you have a y. It's the same as making an input-output table. We're just plugging it in and finding out what y is. Now if I let x equal 0, I can certainly let y equal 0, because then that would go away and I can find my x-intercept. So I'm going to say let y equal 0, which means I will leave my x plus 4 times 0 is equal to 12. That will go away. Anything times 0 is 0. 3x is equal to 12. Divide by 3. X then is equal to 4. You have the ordered pair of 4, 0. That's how we use intercept form. I will let x equal 0 to find my y-intercept. I will then let y equal 0, and I can solve and find my x-intercept. And again, this gets redundant, plugging 0 in over and over and over again. What I like to do, well, I'll just show you what I would like to do on the next one. We're just going to do it out that way. I'm going to graph this in a little XY coordinate plane. And this is where the graphing comes in. And yes, you're going to do several of these. Graph paper makes it easier. If you don't, you can certainly do this on just lined paper or even copy paper. Here's my x, here's my y, and now I graph my intercepts. I've got the ordered pair 4, 0. 1, 2, 3, 4. That's the ordered pair 4, 0. Then I have 0, 3. That's that point. Here's my x-intercept, which I found right here by letting y equal 0. This is the ordered pair 4, 0. This is the ordered pair 0, 3. And again, notice, x is 0, I found y. Y is 0, I found my x-intercept of 4. I will connect those lines. That's all I need. 2 points. And I have just graphed using intercept form. I have found out where this line crosses the x and the y axis by using my brain and knowing that anything that lies on the y-axis, x is 0. Anything that lays on the x-axis, y is 0. These go super quick once you pick up on what they're doing. Here's the next one. We're still gonna graph it. And I have x plus 3y is equal to -9. I am gonna go quick on this one because here's how I like to set mine up. It's in standard form. When I see it in standard form, it lends itself nicely to find the intercepts. And if I look at what I'm gonna do, it's gonna be the same steps every time, especially when this c is divisible by the a or the b evenly. Because I know if I let x equals 0 and I solve for y, -9 is gonna have to be divided by 3 to find my y-intercept. It's gonna come out nice and clean. Here's the way I set these up though. I say, well, I need to let x equal 0 and I need to find my y-intercept. And then I need to find my x-intercept by letting y equal 0. And now I'm just gonna substitute these in. If x is 0, this will go away. You are just left with 3y is equal to -9. 3 times what number gives you -9? Well, it would be -3. And I can write that out. You could write 0 plus 3y is equal to -9. I could divide by 3. Y is equal to -3. You can certainly go through that every time. I just like to do them mentally. If x is 0, I've got 3y is equal to -9. I can tell right now that is going to be -3. Why is it -3? Because I substituted an x and I solved for y. Now though, your y is equal to 0, which means that is going to go away and you are just left with x is equal to -9. I'm going to put this into a coordinate plane. Here's my x, here's my y. I have the ordered pair 0, -3. There's 0, 0, 0, -3, right there. That's the ordered pair 0, -3. That's what I found right here. And then I have -9, 0. Now, this I scale by 1s. This I think I'm going to go by 2s, just to make it easier. -10. So -9, 0 would be right there. I connect my dots, I throw some arrows on the end of my line, and I got it. I love using intercept form. Once I pick up on identifying and I'm given choices of how to graph, intercept form is something that students don't remember to do sometimes, and it makes life much easier. We'll definitely revisit that when we do slope intercept form next. Last example, 2x minus y is equal to 4. And again, I'm going to do it the same way. I will let x equal 0 and try to solve for y. Then I will let y equals 0 and I will solve for x. Now on this one, be very careful. That's a -y there. I will plug that one in. I don't really have to though, because if I have -y is equal to 4, it's got to be a -4, right? But if I plug in 0, that would go away. Just don't forget that I don't want this -y value. You would divide or multiply by -1, which gives me a positive y, which makes this a -4. Just be careful when that y is negative or that x is negative that you're dividing by the negative. If y is 0, well, that goes away. You got 2x is equal to 4. I would divide by 2. X is equal to 2. There's my intercepts right there. Easy enough to graph. I'm going to make a little graph. Little XY coordinate plane. Here's my y, here's my x. I have the point 0, negative 4. 1, 2, 3, 4. I have that point. 0, negative 4. My y-intercept, my x-intercept. 2, 0. And now I can connect those two dots. Whoops, I was a little off on that one. Close enough, I've got it labeled. And I'm done. To graph an intercept form, we are going to let x equal 0 and find our y-intercept. Then we will let y equal 0 to find our x-intercept by substituting those values of 0 into the original function or equation given. There is a other little video, nice little Khan Academy video attached. That'll be a nice supplement. Give it a watch as well.